Graphing rational functions, part 2. Sweet. Okay. So the homework was 26, okay? The homework was 26. How did we do with that? Were there any questions? Did people get confused? This is the homework. Just doing this one problem from the notes. Yes? Yeah, EVA, yep. So remember to find our end behavior asymptotes, right? That's the horizontal red dashed line, right? That the graph can't touch. It gets really close to, but it doesn't touch as we go to the right or left forever. All right. How do we find that again? Does anyone remember? You remember how we find that? What do we do? What do we look at? Yeah, exactly. Good job. We look at the degree of the numerator and the degree of the denominator, okay? So what's the degree of my numerator here? The highest, right? The degree is the same as the highest exponent. So what is it up here? 2. What is it in the bottom? 2. Okay, what do my instructions say? When the degrees are equal, the end behavior asymptote is what? It's that lead coefficient of the top over the lead coefficient of the bottom. If we forget what a lead coefficient is, right? It's that number that's next to our highest degree term here, okay? So on top it's 1, on bottom it's 1. So our end behavior asymptote is 1 over 1, which is just 1. Does that help? Okay, cool. Okay. All right, so remember, we find our excluded values. We got our 2 excluded values here. Okay. Which one was my whole and which one was my vertical asymptote? How do you know whether an excluded value is a whole or a vertical asymptote? We talked about this, what, 3 days ago now? Yes? Yeah, so my whole, right, if there's an excluded value, so here, this x plus 4 factor gave us an excluded value of x equals negative 4. Since it got canceled, right, since it canceled with a factor in the top, it's called what we call a whole, okay? And then our vertical asymptote is the excluded values that don't cancel, right? And that's going to be our vertical orange lines here on this graph, okay? All right, domain, you should know that from 6.1. X-intercepts, how do we find our x-intercepts? Yep, we set the top equal to 0. We set the top equal to 0. Well, I should say the simplified top, right? This x plus 4 gets canceled, so that doesn't count as an x-intercept. It's just the top factors that don't get canceled. We set those equal to 0 and solve, and those give us our x-intercepts, which are points. They're points, okay? Then our y-intercept, we plug in 0 for x. We get out the y-intercept, okay? All right, so the only difference here, the only difference from the few we did the previous class was we had a hole here, okay? We had a hole in this one, okay? So the hole was at x equals negative 4. So one thing I want to say, if you graph this in your calculator, when you graph this in your calculator and you're done drawing the graph, you'll see something like that. And then what you have to do with your hole here is you just go to x equals negative 4. So right here, I'm going to go up to my curve. So I'm going to go from x equals negative 4. I go up to my graph, and I just draw I'm just going to draw a hollow circle there. Okay, I'm just going to draw a hollow circle. That's how you plot a hole in your graph. So it just looks like a hollow circle, right? Just one point, a single point of our graph is gone, okay? All right, so let's do some more examples because I think we're still a little shaky with this. So let's do 24, okay? So this will help, okay? What's my first step? What's my first step when I do one of these? I want to factor everything, right? So I'm on number 24. It's on page 5. Some of the pages in the numbers might be a little bit out of order, but it's just the next page. Okay? First thing I do is factor. First thing is factor. Factor first. Okay? If you don't know how to factor, you're in hot water. Okay? What can I do with the top? Yeah, I can pull out a GCF, right, of negative 3. So that's going to give me negative 3 times x squared minus 9. Good. All right, and then what does that factor to? Yeah, good job. So I have a difference of squares right here. So x plus 3, x minus 3. All right. What does the bottom factor to? Let's see. Let's build our shell, our little trinomial shell. My signs are plus and minus. Okay. So think difference. We want two factors of 6 whose difference is 1. Let's 3 and 2, right? So I want the 3 to go next to the plus since I want to have a plus 1 left over. Okay, so you guys should know how to factor by now. If you don't, you need to come to me outside of class and practice, okay? So there we go. All right, so what are our excluded values here then? What do we do for excluded values if we forgot? Yeah, so we take the bottom, we highlight the bottom, we write the bottom equals 0, and then we solve, right? So we take each individual factor here, and we set it equal to 0, and we solve for x. So that gives us x equals -3 and x equals 2. Which one? And then let's notice here, guys, these x plus 3's are going to cancel, right? Okay. So of these two excluded values, which one's going to be my whole? -3, right? Because it cancels with a factor at the top, okay? So x equals -3. Which one's going to be my vertical asymptote then? X equals +2, right? So remember, the whole is just a little circle we draw in our graph. I'll just write a little circle. Okay? And then a VA, a vertical asymptote, is going to be a dashed vertical line that we're going to draw. What's my domain going to be? You should know this from 6.1. It's always all real numbers except for those two excluded values, okay? Or in this case, except for my holes in my vertical asymptote. So it's going to be -infinity, comma -3, union -3, 2, union 2, comma +infinity, okay? All right. And how do I find my x-intercepts? Set y equals 0. Good job. Yep. So we're gonna go. We're not gonna worry about this guy we crossed out, okay? But we're gonna set this other factor here equal to 0. So we set the top equal to 0, and we solve for x. And we solve that for x, okay? So we set each factor on top equal to 0 and solve for x. So that gives me x equals +3. The -3, yeah. So once we've canceled this factor out, we write down that it's a whole, and then we just forget about it.
I meant the -3 on the other side.
Oh yes, the -3 right here. Yeah, so you can try setting that equal to 0 and solving for x, but what do you get? It's just no solutions, right? So you just want to worry about that. Does that make any sense? Yeah. Yeah. So it's all the factors that have a variable in them. The ones that are just constant numbers, you can set those equal to 0, but there's no solutions for those. Okay. All right. So x-intercepts. My x-intercept is what? It's a point, it's a line, it's a circle. What is an x-intercept? That's a point, right? That -3, that +3 there, is that the x or y coordinate of my x-intercept? It's x equals 3, so it's the x coordinate. Yeah. What's the y coordinate of an x-intercept? Always 0. Yeah. Remember, it's kind of flip-flopped. X-intercepts have y equals 0, and y-intercepts have x equals 0. Okay, it's flip-flop. Just we talked about that graphing lines, right? Right. You wanted to find the x-intercept, you had to plug in 0 for y. You went back and forth. Okay. A y-intercept has a which coordinate's always 0 for a y-intercept then? X. Yeah. Okay. Then how do we find that missing y coordinate? What do? We plug in. We do f of 0. Okay. Plug in 0 for x, okay, and that's going to give you the y coordinate of your y-intercept, okay. So you can use either your factored form, or you can use your original unfactored form for finding f of 0. I like to use the unfactored form, so I'm going to do -3 times 0 squared plus 27 all over 0 squared plus 0 minus 6, okay. That's going to give me 27 over -6, which simplifies to, is that -9 over 2? Thank you. It's going to simplify to -9/2, okay? So my y coordinate down here, my y-intercept is going to be -9/2, okay? Let me color code these. So I'll do the x-intercepts as green. I'll do the y-intercept as blue. Sorry about that. All right. And then again, how do I find my end behavior asymptotes? How do I do that? What's that? Look at the degrees, right? So I'm going to go back to the unfactored form, okay? It's easier to see the degree there. What's the degree of the top? 2. What's the degree of the bottom? 2, yeah. Okay, so what do we do in that case? What do we do? We got to look up here, right? It says divide the lead coefficients. Divide the lead coefficients, okay? So my lead coefficient on top is what? -3, right? It's the number next to x squared. What about on bottom? It's technically a 1. Yeah, there's a 1 right there, okay? So my end behavior asymptote is going to be y equals -3 over 1, or just -3. Okay, so I got all my information written down. I have all my information written down. Now I'm ready to start graphing, okay? So let's draw in my vertical dashed line, okay? We wrote down pretty good instructions for this, I think, the other day. Okay, why is my iPad frozen? Okay, never mind. All right, we're going to, here we go. Going to do vertical asymptotes and my end behavior asymptote. All right, so good color-coded instructions. Okay, so let's plot our vertical asymptote as a dashed vertical line. So what's my vertical asymptote? It's x equals 2. So I'm going to do a vertical line through x equals 2, just like that. Okay. Let's do my end behavior asymptote over here. Y equals -3. We should know how to graph that. All right. There we go. Are we doing okay? All right, and then let's plot my x-intercepts. Okay, there can be multiple of these. The point 3, 0, okay? So I'm going to go right 3 and up and down 0. So right there on the x-axis. That's why it's called an x-intercept. It's where the graph crosses the x-axis. It's where it intercepts the x-axis. Okay. All right, my y-intercept. 0, -9/2. Okay, that's the same as -4.5. So I'm going to put it, x coordinate is 0, so I don't go left or right at all. I go down -4.5. Okay. And I think, what do I do at this point then? What do my instructions say? Plug into calculator and sketch. Okay, so let's get our graphing calculators out, please. Let me, I need a packet so I can. 124, right? All right. Good stuff, okay? All right, so I'm going to go to that y equals screen. Does anyone remember how to plug these into your calculator? What do I do?
You do parentheses.
Yeah. So I put the top, I put that numerator in parentheses, okay? So negative, make sure you hit negative and not minus. So negative 3x squared plus 27. Okay, now what do I do, Joey?
Then you click the divide button.
Divide by button, right? And then in this bottom, that denominator right here, that bottom polynomial needs to go inside of the parentheses, okay? So x squared plus x minus, make sure you hit minus and not -6, -6, okay? Make sure you put negative symbols where there are negatives and minus symbols where there are minuses, okay? You guys following so far? Sweet, okay, good. How can I make sure my window looks good? What can I do? Hit zoom, standard, okay? Cool, all right? So let's make sure, I'll give you every couple seconds, let's make sure we can get that on our calculator screen, okay? So do you guys see how there's two parts to this graph? There's like a little upside down swoosh right here, and then a little right side up swoosh. Let me get my Apple Pencil. There's a little upside down swoosh here, a little right side up swoosh, okay? So to the left then, and this to the, oh no, where'd it go? Oh, here it is, here we go. To the left then of my orange line here, I'm going to draw that upside down swoosh, okay? So in this bottom left box, okay, our two asymptotes form like four little boxes. In this bottom left box, I'm going to draw that upside down swoosh, right? So it's got to get really close to touching my end behavior asymptote, but it doesn't touch it. Got to make sure it passes through that y-intercept, and then it'll go down to infinity, right, at that vertical asymptote here, the orange asymptote, okay? All right, and then that upper swoosh, that right side up swoosh in this top right region, right, it's going to be boxed in by my orange vertical asymptote and my red end behavior asymptote, okay? So it's a swoosh, and it's a swoosh that the ends of it follow those two lines, those two colorful lines, and make sure it passes through that x-intercept there, okay? It has to pass through all the points we plotted, okay? So I'm almost done. What's my last thing I need to do? What's my last thing? Hole, right? We need to do our hole. How did I tell you guys to do holes? So I'm going to do this in pink. So what's my hole here? X equals -3, right? Okay. So I'm going to go to -3 here. -3 here on the x-axis. I'm going to go down to where it intersects my graph, and I'm just going to put a little pink circle there, okay? All right, you guys feel okay about this? Good. All right. All right, so are you guys seeing then, like, right, your graphing calculator is good, but it doesn't give you the full picture, right? It doesn't exactly give you the full picture. Okay, so let me just check. Let me check the new schedule real quick to confirm. Hold tight real quick. So we need to come back here at 12:50, okay? 12:50. 12:50, 12:50. What's that?
Were you near any people that passed out?
No.
I don't know why they didn't. Why they
It's
weren't.
just like
It's like,
a
okay, like, go home.
Thank you, sir. So they graph on their calculator and the paper?
So the way Jen told me. So yeah, the calculator gives like a good rough picture of it, but it doesn't like show all the details. Like, so we kind of plot the details on our own, and then next year they'll do it by hand. But
Clever. I like that.
yeah,
Wait, we have to learn how to do that by hand?
yeah, it's not too bad.
Wait, I mean, I guess I technically could just do a three-handed either way.
You guys haven't learned how to make a sign chart yet. All right, I need to eat my lunch.
Yeah. So do I.
You didn't pass out. Give us. Got it. All right, guys, let's keep going. So here's what we're gonna do. So I have, how far are we up? So we've gotten, I'm at different places in my different classes. Like what are we needing here? Probably 15. So let's do 25 on our own, okay? And I'll be around to help people, okay? So I want to help you guys figure out how to do this on your own. Okay, so let's do 25. We're going to do 25 on our own, okay? There's no holes. It doesn't have to have holes. They just both be asymptotes. Yep, good job. Oh, excuse me. Let me graph it myself real quick.
No, that's literally all I have. I knew I had it. I didn't know where it was.
Yeah.
I see it. It's really down. It's like really cut. No, it's. I mean, it's still there. Is it on your ground? Bro, it's so. Bro, it's still there. Oh, no, it's not. Oh, can you try? It's not there.
I've never seen you.
Okay.
This looks like you.
Bless you. Yeah, so hang on one sec. So I think it's this. Okay, 1 second. Okay. What's up?
Oh.
In the top?
Oh, I think
Yeah, so let's put your X intercepts. There's none. Help me? 25. what are the three cases? What do you mix? So we would divide the lead coefficients if the degrees are the same. Right? What's the degree at the bottom? 2. What do we do when the degree at the bottom? Looking notes. So when the degree of the bottom is bigger, and behavior asymptote is just y equals 0. So it's just the x-axis. You're gonna be none. Just say none. So don't say 0, 0. Just say none. This is what you want to go over. There's no x-intercepts. No, because the top three never equals 0. Just say right none. Yeah. And check your answer for y-intercept. No, there is a y-intercept. There's a y-intercept. Negative 430. You can't do y. You're on the right track. It's 0, comma what? So you plug into 0. Plug in 0 there. You get 4 over. I think you factored that wrong. We'll factor it.
Oh, I
Positive 3. Positive 3 and then good answer. Cheat, you're good. You're good.
I just wrote it.
Are you done already? Yeah. I'm trying to gauge how long these take us. I think I'll have this do 5 for homework.
5
5
problems.
for these graphic ones. She's already done. I'm trying to balance it out. Oh, you're not done? Yeah.
Go back to how.
Actually, you got it yet, so how do you grab it? Now you're ready to grab. Yes, you 2 vertical asymptotes, right?
Where is
The holes, yeah, so it's going to be excluded values, right? So we take the excluded values, we classify them from holes and dx. So holes are when it is. Holes are ones that are excluded values that is.
And neither, but none of them.
No, it should just be none.
Oh, this is
Yeah, there's both.
Okay.
So I'm trying to gauge how long these take us. Oh my God. I don't know if I can do that. That's your y intercept, right? So it never touches the x-axis. Y intercept. Y intercept is actually plug in 0.
Yeah, but no, we,
0 plus 3 is 0 minus
so
1 is
oh
negative.
no, it was Gavin.
But your graph looks great.
He told me, Billy told me they were going to real.
Yeah. Okay, so that's what the graph looks like, right? So
They'll still have.
that's what it looks like your calculator. But from here, you've got it y. Yes.
That's probably Luke's header.
Yeah, you have to. Yeah. Let me. I think I have better notes than a lot of people, so maybe I'll airdrop my notes.
How?
Good. Share. Just made a little mistake. The y-intercept is on the x-axis. Yeah. There's no x-intercepts. You're doing great though. You're close there. EVA, yeah. So this is can I share my notes with you?
Yeah. It's.
So the bottom has a greater degree. What are
That would be deadly.
bottom has a greater degree. Alright, so you got that done. That wasn't too long. Think I'll do facilities for homework. Let's do 4. I'll give you guys like 4 topics. Alright guys, so your homework then. I should probably turn this off.